Linear relations. Linear relations are relations where the data values all lie on a straight line. Linear. The graphs of three relations are shown below. Circle the linear relations, he says, drawing. I want a thin line. Circle the linear relations. Well, this one looks linear. State the domain and range and whether the data is discrete or continuous. So here's a circular. Well, it's an oval. Domain. Now you notice we can't say it goes from 0 to 50, right? We could say it's 0, 10, 20, 30, 40, or 50. So the domain is a set of numbers. 0, 10, 20, 30, 40, 50. The range is a set of numbers. 400, 900, 1400, 1900, I think. 400, 900, 1400, 1900, 2400, and 2900. It's discrete data. So it's linear, it's discrete. Domain and range are sets of numbers. And I think we've done it. This is not linear. The domain, 10, 11, 12. Is that 12 and a half? I'm going to go with 12 and a half. Domain 0 is less than or equal to, we don't have labels, but time and height. So let's put t. T, which is less than or equal to 12.5. And the range is 800 to 0. So 0 is less than or equal to h. So remember, lowest value, less than or equal to variable, less than or equal to highest value. And this data is continuous. This is linear. Domain. Okay, it's all values from 0 to 20. We got time and altitude. I'm going to call that T. Call that A. So time goes from 0 to 20. Altitude, 10,000 down to 0. So 0. Low value, less than or equal to. We will never write this the other way. It's always the lowest value is less than or equal to the variable, which is less than or equal to the highest value. And the straight data is continuous. Put pen down. Complete the table of values for relation A. Number of guests and cost. We better go back here. So that was $400, and so 0 guess was 400, and then 900, and so on. Okay, so 0 guess, $400, 900, 1400, 1900, 2400. 2900. Note that for relation A linear relation, every increase of 10 guests results in an increase of $500 in cost. Let's go to relation B. So we want heights for 0, 2, 4. I'm going to fight between 0, 2, 4, 6, 8, and 10. 800. Some number. 800, 780, 710, 610. 800, 780, 710, 610. 480 and 300. Okay, so whereas here, for every 10 guests, we went up by 500. This is not a linear relation. Every increase of 2 seconds results in a different decrease of height, right? This is minus 20, minus 70, minus 100, and so on. So this is not linear, or the fancy way of saying that is non-linear. For a linear relation, a constant change in the independent variable, that's our x value, right, or t, or results in a constant change in the dependent variable. So a constant change in the independent. For every 10 change in this, there was a 500 change in that. So a constant change in the dependent variable. Which of the following relations are linear? Okay, so we go 5, up by 5, up by 5, up by 9, up by 9, up by 9. This is linear for every 5 degrees Celsius. We go up 9 degrees Fahrenheit. Up by 5, up by 75, up by 5, up by 225, up by 5, up by 375. Non-linear. Whoops. Give me my pen back. Non-linear. I don't know if that should be underlined. Maybe it should be circled because it's non-linear. A new car purchased for 24th is, let's say it's is purchased. A new car is purchased for, we need a verb in that sense, is purchased for $4,000. Every year the value of the car decreases by 15%. The value of the car, V, is related to time. So we need to look. So every year the value of the car decreases. Will 15% be a constant amount? And the answer is no, it won't. And let's get the calculator out. And let's get out of the graph. So it's $24,000. 15% times 0.15. So it will decrease by 3,600, which means that it's now worth 24,000 minus 3,600, is 20,400 times 0.15. So it goes down by 3,600, then down by 3,060. So this is non-linear. Don't do that. Give me back my pen. Non-linear. For a service call, an electrician charges a $75 flat rate plus $50 for each hour he works. The total cost for service is related to the time. So time 0 would be $75. That's just to show up. Time 1 will be 125. Times 2 will be 175. So initially it's not linear, but actually, wait a sec, if we go up by 1, we go up by 50, up by 1, up by 50. So it is linear. 225, up, oh gosh, I know what I'm doing. So this is linear. Every increase of 1 hour results in an increase of $50. Okay, what's going on here? We go up by 3, up by 3, up by 3. So we go down by 4, down by 4, down by 4, down by 4. This is linear. Man. State whether each of the following is a linear relation. Explain. Up by 2. I'm off the pen again. Up by 2. Up by... Okay, so if we go up by 2, we go up by 100. Up by 2, we go up by 100. Up by 4, we go up by 100. So that's non-linear. Since the last jump is x by 4 and y still goes up by 100. Up by 10, down by 20, plus 10, minus 20. Up by 5, down by 10. Up by 10, down by 20. So I think every 10 we go, every 5 we go then would be 10. So this is linear. Change of 10 results in a change of down by 20, and a change of 5 results in half that change. Linear. Wait a sec. Is that the... No. Whoa. Hang on. There was more. If each of the following are linear relations, find the missing values. Okay, if we go up by 2 plus 2, we're going down by 8. Up by 2, down by 8. Up by 2, down by 8. Up by 3, well, what does that mean? If we're going 2 and down 8, then if we go down 1, that's down 4. So this will be down by 12. So for every 1, we go down by 4. So if we go down 3 ones, we go down by 12. I went up by 8. We went up by 26. So going half of that should be going half of 26, which is up by 13. And then up by 13. And then we go up by 4. So for every 4, we went up by 13. But we've gone up by 6, which is 1.5 times 4. Well, maybe we figure for every 2. For every 2, then, we'll go up by half of 13. 13 halves. We go up by 6. For every 2, that's 3 of those. It'll be like 39 halves. Or 19.5, which I believe gives us 52.5 to get a linear. And we'll take a look at this in greater detail. What's the only thing we know here? These are going up by 3, up by 3, up by 3, up by 3. This went from 7 to something to something to 31. So if it's linear, we need sort of 2 jumps. So what do we got? 1, 2, 3 jumps. So let's do that a little mathematically. 7 plus 3x is equal to 31, right? I had 1x, 2x, 3x. So So 3x is 24 and x is 8. So we go 7, 15, 23, 31. And if we're going up by 8 this way, then we must be going down by 8 this way. Add 8, add 8, add 8, add 8. Okay. Rate of change. So how much are we changing? Wow, this is like calculus. The rate of change of a linear relation is given by rate of change is equal to the change in the dependent variable, usually y, over the change in the independent variable, x. For each linear relation, determine the rate of change. Include units with your answer. Explain what this rate of change represents in words. Okay, so for every 10 guests, we are going up $500. So it's $500 per 10 guests, or $50 per guest. So the rate of change is $50 per guest. So each additional guest costs us $50. So rate of change, $50 per guest. That's what it represents in words. Altitude. Altitude. So we are going down in 4 minutes. 1, 2, 3, 4. We're just sort of missing a little. Missing the 1, 2, 3, 4. 4. Well, all right. I don't know. Let's see. We go from 10,000 down to 6,000. So that'll be down 4,000. And we do that in 6, 7, 8 minutes. So down 4,000 meters in 8 minutes, which will be minus 500 meters per minute. If we divide that out, we're going down 500 meters per minute. Distance and volume of gas. So for every 100 kilometers we use, remember, it's this rate of change, so it's minus 15 liters. It's 15 liters per 100 kilometers, which is actually the unit that we use to measure fuel in liters per 100 kilometers. So we could leave that, or we could say it was 0.15 liters per kilometer. This actually matches up with what the fuel consumption people give us, and then this is the actual rate. Hours of use. 2 hours. Cost of internet and hotel goes up by 4. So after the first 2 hours, it is $4 for every 2 hours. So after the first 2 hours, it's $2 per hour. After the first 2 hours, the cost is $2, $4 for 2 hours, or $2 per hour. C of n, function notation. Cost as a function of number is 25n plus 200, where C is the cost in dollars and n is the number of guests. It's a $200 flat fee, but the rate of change is $25 per guest. M is 30 minus 1.3 t, where m is the mass in pounds and t is the time in seconds. If we had wanted to write that as a function, it would look like that. Okay, but we didn't. So every second we're down 1.3, so it's minus 1.3 pounds per second. Woohoo, and that's it. So we're done with linear relations and rate of change. Wow, we've barely brushed the surface, but for today we're done.